All right, so we're going to be talking about solving some questions involving distance, rate, and time questions. Whoops. Using a rational equation. So in order to do that, I'd like to first start off by saying the thing that we're going to be using is, it's going to look fairly similar to what we've done before. We're going to use our distance formula. And remember that distance is equal to, rate times time. And frequently what you're going to find with things like this is the question is, what's happening with the rate? So usually the main question on how to set things up, it really kind of centers around what is the rate. Because frequently you've got something like a vehicle. This could be a plane, this could be a boat, and it's going to be either going with or against some sort of current. So this could be a plane going with the wind, or a boat going with the current, or against the current, something like that. So your rates are always going to look like this. Your rate is always going to be, it's the vehicle first, and then it's going to be plus or minus the speed of the current. So let's take a look at what the setups on these are going to do. So for example, the speed of a boat in still water is 5 miles per hour. If the boat travels 3 miles downstream, as it takes to travel 1.5 miles upstream, what is the speed of the current? So here we've got the speed of the boat. We know that the speed of the boat is 5 miles. We don't know what the speed of the current is. So when I look at, when I say, okay, well, I've got my rate times time is equal to distance. I'm going to have, I can think of this as like downstream. I have a very, very helpful TA in the background. And I've got upstream. Downstream means I'm moving with the stream. So it's going to be this vehicle plus the current. So here I would say this is going to be 5 plus the current. Upstream is going to be against the current, so it's going to be 5 minus the current. And I know that it was 3 miles downstream, and it was 1.5 miles upstream. What I don't know is the time. And this is where we have to take our first sort of cognitive jump. I know that rate times time is equal to distance. But one of the things that I could do is if I wanted to, I could take this rate times time equals distance, and I could solve this for the time, since I don't know what that should be. So I'm going to divide both sides by r, and I'll find out that my time is going to be just the distance divided by my rate. So this time right here is going to be 3 divided by 5 plus c. And this time, well, it would be 1.5 over 5 minus c. It's the distance divided by the rate. Now one of the things that's kind of hiding in here is that it's the same amount of time. If the boat travels 3 miles downstream, in the same amount of, oh, yes, I didn't write that down, in the same amount of time as it takes to travel upstream. So these two things are going to be equal. So now we can just go ahead and set these two things equal and solve. So what I'm going to do is I'm going to set these two expressions equal. This is going to be 3 over my 5 plus c is equal to 1.5 over my 5 minus c. And we can solve this from here. Whenever I solve an equation, I'm always going to multiply through by my common denominator. It looks like my common denominator is going to have all of the factors in my denominator. So it looks like it's going to have a factor of 5 plus c and a factor of 5 minus c. So 5 plus c and 5 minus c. And the nice thing is, because it's a common denominator, it'll always cancel out. So I'll have 3 times 5 minus c, that's going to be 15 minus 3c. This is going to be equal to 1.5 times 5 plus c. That's a little tougher. That's going to end up being, I want to say, what is that? 7.5 plus my 1.5c. But now I'll be able to, but from here I can do something and solve this equation. I won't say it's trivial. It still takes a little bit of effort. I'll subtract 7.5 from both sides. And I'll go ahead and, so that way I've got, 7.5 minus our 3c is equal to our 1.5. I'll add 3c to both sides. Oops. So I'll have, this is not working quite as smoothly as I'd hoped it would be. 7.5 is equal to our 4.5c. And oops. When I divide, I'll divide both sides by 4.5. And on these, you should, I believe, have access to a calculator. And actually, this one's going to come out to be a little bit interesting. And if I were looking at this, I could probably break this down to about 1 2/3. And just thinking about that, I could say, okay, 7.5 over 4.5. I'll multiply this by 10 over 10 to get my decimal point over. So that'd be 75 over 45. And I could divide both of these by, I know I could divide both of these by, it looks like 15. When I divide by 15, I'll end up with, let's see here. Actually, could I divide that by 15? That's an interesting question. Yeah, that would end up being, that would end up being 5/3. So 1 2/3 is equal to my current. So my current is going 1 2/3 miles per hour. That's a little bit, I'm, that's, and that's our basic process. Okay, let's move on to our next example. Current of a river is 2 miles per hour. A boat travels 8 miles upstream in the same amount of time, and back again in 3 hours. What is the speed of the boat in still water? So we have ourselves a boat. Here we are. And we're going up the river about 8 miles upstream and back again. So our question is what is the speed of our boat? And once again, rate times time is equal to distance. And we're told what what the speed of the current is. The current is 2 miles an hour. So if I take a look at like upstream and downstream, oops, I'm gonna move this over. So if I've got my upstream and downstream, then that'll give us then here we're going to end up with like our boat. Upstream is going to be, speed of their boat is going to be this, and it'll be like minus that 2 miles per hour. Downstream, it's going to be the speed of our boat plus 2 miles per hour. But the distances staying the same. It's 8 miles. Now, with this, we know we can figure out what our time is. And time is going to be our distance divided by the rate. So this is going to be 8 over b minus 2. Then I'll have 8 over b plus 2. Now we're going to need to figure out, and then we have to say, oh, it does all of this. It goes there and back again in 3 hours. So if I were to add together these two times, my sum should be equal to 3. So I will have that 8 over b minus 2. And I'm going to give myself some space here because I want to leave some space to work. I'll have 8 over that b plus 2, and I know that that sum is going to be equal to 3. And whenever we're solving something like this, I wonder if people ever get tired of me saying, you're going to multiply by your common denominator. So our common denominator has to have all the factors of my denominator, so it's got to have a factor of b minus 2. And it's going to have a factor of b plus 2. All right, let's do this. when I do this, everything's going to get distributed. So everything is going to be times b minus 2 and b plus 2. And good news is, a lot of this is going to cancel out. So here I've got b minus 2's are going to cancel out. So I'll have 8 times my b plus 2. Here my b plus 2's cancel out. So I'll just have 8 times by my b minus 2. And over here, I'll have 3 times our b minus 2 times our b plus 2. Let's take a couple steps to simplify this now. I'll have 8b plus 16. And then when I distribute here, I'll have 8b minus 16. Oops, it's not 18, 16. And this is going to be equal to, I'll have 3 times, this is going to be the difference of squares. It's going to be b squared minus 4. That is, I'll have b squared plus 2b minus 2b minus 4. So ultimately, when I put these things together, I'll end up with 16b, and plus 16 and minus 16 go away. This is going to be equal to 3b squared minus 12. Oh my gosh. We're left with a quadratic equation, but that's okay. That's something that we should be able to solve. I'm going to go ahead and subtract 16b from both sides. So I'll end up with 0 is equal to our 3b squared minus 16b minus 12. And from here, let's now we get to factor this thing. 3 times negative 12 is negative 36. We need a factor pair of negative 36, so that's going to add up to negative 16. And let's see, I could do 1 and negative 36, 2 and negative 18, and there it is right there. So this is going to be 3b squared plus 2b minus 18b minus 12. I'll factor a b out of these first two, so I'll have 3b plus 2. Out of these two, it looks like I can factor, what can I take out of that? A 6? Yeah, 6. I'll take a negative 6 out, so I'll have 3b plus 2. And then I'll factor out my common factor of 3b plus 2. And b minus 6. And this is all still equal to 0. Set each factor equal to 0. I'll have 3b plus 2 is equal to 0. I'll subtract 2. I'll end up with 3b is equal to negative 2, or b is equal to negative 2/3. And just right off the bat, I'm going to point out that if our speed here is negative, then the boat is traveling backwards. That seems unlikely. Or b minus 6 equals 0. That'll give us a speed of 6. That seems a far more likely thing. So our boat isn't traveling backwards. So I'll say that our boat travels 6 miles per hour. All right, that's what we've got for this question.